So you watched the video that dealt with the history of the periodic table. Okay, on that video, you discussed two gentlemen. We're going to add a little bit more names. Okay, we're going to add a couple more names to our list of the history of the periodic table. But the ones that we discussed yesterday were two of the biggest players in the periodic table. Who were they? Who were the two guys we discussed yesterday? Dana? One was Mendeleev, Dmitri Mendeleev, Russian scientist. What Mendeleev did, okay? What Mendeleev did was he was the first one to start to group these elements together. Okay, he started to group these elements together. Why, thank you. Who was the other one? Who was the other individual? You should have this on your notes, folks. Come on. Who was the other individual? Yeah, Kayla? Moseley. So Mendeleev and Moseley were the two guys that we hit on the video yesterday. Okay? Now, the history of the modern periodic table. The 19th century. Chemists began to categorize the elements according to their similarities, the properties, the physical, the chemical properties. Johann Dobereiner said that he's going to classify these elements into what he called triads. He called them triads because they had similar properties. And if you look, okay, he said chlorine, bromine, iodine was a triad. Well, that makes sense because they're all on group 17 of our periodic table, right? Groups down have similar characteristics. So that makes sense. Look at calcium, strontium, barium. Okay? Same thing. They're group 2 of our periodic table. So that makes sense, the way he had these triads. All right? The way he dealt with the triads. Newlands came through and he said that I'm going to arrange the elements into what I call octaves. Okay? He did so because he realized that there was a pattern that was repeating after every 8th element. Okay? Oct is 8, so that's why he has octaves. So we started out with triads, then we come into octaves, but nonetheless, we're seeing that these scientists are grouping the elements together. Okay. Now here are some groups. Okay, here are some groups where the repeating pattern is occurring. But Mendeleev, 1869, Dmitri Mendeleev published a table of elements. Okay? He put these elements in order of increasing atomic mass. So in his periodic table of elements, okay, his periodic table of elements, he had the masses. He grouped properties, put them in order. At the same time that Mendeleev was doing this, a guy named Meyer was also doing the same thing. Okay? At the same time, Meyer also published his table of elements. He organized his table by increasing atomic mass. Now, Here's the thing. Mendeleev, Meyer, same time, same thing, atomic mass. Okay? How come do we credit Dmitri Mendeleev with discovering the periodic table and not Lothar Meyer? Okay? Both of them were arranged in atomic mass. Okay? Both of them arranged in atomic mass. Both left vacant spaces. Both of these folks said, hey, I'm going to skip a spot here because something goes there that we don't know yet. We have not discovered that element. We don't know. I'm going to leave a space. So why Mendeleev? Why not Meyer? Why not say, hey, both of these chaps, both these guys? Well, here's the deal with Mendeleev. Here's the deal with Mendeleev. He said that if the atomic weight of an element caused it to be placed in the wrong group, then the weight must be wrong. And he corrected atomic masses. Look on your periodic table. Okay? Look on your periodic table. I want you to find iodine, element number 53. Look at the atomic mass of iodine. 126.9045. Now, look right to its left, tellurium. Tellurium has a greater mass, right? Tellurium has a greater mass than iodine. So when Mendeleev first put those together, they were in different orders. But that's where he said this stuff up here. That weight must be wrong. Because when I group them according to properties, I should flop iodine and tellurium. The properties don't match when I line them up with weights, so I'm going to flop them. He said those weights can't be right based on my theories of this periodic table. Okay? Also, Mendeleev was so confident that he used his periodic table to predict properties of elements that were not yet discovered. So he said, I'm leaving this blank here because something fits in there. We don't know what it is. Something fits in there. And that element is going to have these properties. How do I know that? Because based on my table, based on the group it's in, I can tell that these will be the properties of that element. So he predicted elements that weren't even in existence yet. Now, the big breakthrough was after the discovery of some of these unknown elements. And the fact that Mendeleev's predictions were amazingly close to the actual values. So he predicted the properties before the element had been discovered, and they were very close. They were very close to the real properties. Okay? Still, there were problems with new elements and the atomic weights. Okay? When Mendeleev said these weights are wrong, okay, they were still coming up with problems based on those weights. Okay? Argon, potassium are a couple of those. Okay? Argon and potassium were a couple of those. Argon weighs more than potassium, but it's after it on the periodic table, right? Cobalt, nickel, tellurium, and iodine, we already talked about. Okay? So there's still problems with this table that Mendeleev created. Along then came Henry Moseley. Along then came Henry Moseley. He was working with X-rays, and he determined the actual nuclear charge, the atomic number of the elements. So when Moseley came around, he ordered his periodic table based on atomic number, which is the number of protons, and not the atomic mass. 1913. Okay, here's just a little fact that I threw in there that I thought was a little bit interesting. Okay, Moseley's research was stopped because the British government sent him to World War I. At World War I, he was shot down by a sniper bullet. Okay? So, I mean, before Moseley's work was even completed, he had passed because they sent him to war. And if you look down the bottom, they later said that if we are sending any of our scientists to war, they're going to be non-combatants because we don't want those individuals to die in war. Seaborg. Glenn Seaborg co-discovered 10 new elements in 1944, and he moved 14 elements out of the main periodic table. He put these below the lanthanide series. So he actually founded a lot of these elements, or co-discovered a lot of these elements that we now call the actinide series. Okay? The actinide series. 1912 to 1999. Those old Seaborgs. Years. He is the only person that had an element named after him while he was still alive. Okay? Element 106. Look at element 106 on your periodic table. Element 106 on your periodic table. Seaborgium. Came after him. Okay? Let's see another one. I know ruthenium. Well, not ruthenium. Rutherfordium 104. Probably named after Ernie Rutherford. Okay, borium. Niels Bohr. We're getting some big time scientists in here. Look at 101. Mendeleevium. I wonder who that was after. Wonder who they named that one after. But Seaborg was the only person that was still living that had an element named after him. And he said, "This is the greatest honor ever bestowed upon me, even better, I think, than winning the Nobel Prize." Okay? So he thought that that was a great honor. So, just a little bit to cap things off, to review. Okay? What is the difference between Mendeleev and Moseley? What is the difference between their periodic tables? Who can tell me that? Who can tell me that? I mean, there's got to be more people in here that talk than the two guys at the back, right? Mason? Moseley did his periodic table based on the atomic number, okay, which is the number of protons. And Mendeleev based his periodic table on the atomic mass, okay, which is based on the protons and the neutrons, okay?